Welcome back. Tonight, we're going to cover a different aspect of vibe coding that a lot of people don't talk about. It's the nitty gritty. It's the behind the scenes. It's what we all need to do, but a lot of people just don't know how to do it. So I've got over 30 years in IT experience, and I'd like to share with you some of the behind the scenes, the way that we version, the way that we do snapshots, all the dirty, the nitty gritty stuff. The vibe coding stuff's fun. It's exciting. But when the database breaks on a Saturday morning, right, and you didn't do the snapshots right, those days are horrible. So my name is Stan Jesnowski. I've worked in corporate America for over 30 years. So I started out as a programmer and I worked my way up to IT management. So most of my career, I was in IT management, but I always enjoyed dabbling a little bit in code. And I really enjoyed the design aspect of it, making sure the backups work and also, the GitHub repositories, making sure that if we ever did have a failure, not if we ever did, when we had a failure, right, that I could restore the data properly so that we didn't shut a factory down or, I was in pharmaceutical research, I was in manufacturing all those years. And even before that, I learned a lot of stuff. I went to Purdue. We went over these things called ERDs, which is entity relationship diagrams. Those are for relational databases. And tonight I'm going to cover those with you too, because I think it's very important to understand how all that stuff works and how it all ties together. I got started programming in 1983 on a VIC-20. I used to get a magazine called a Compute Magazine that had games in there that you could code. And I would actually go through and code my own games because I was the youngest of 11. And quite frankly, we couldn't afford an Atari. So my only choice was to code my own games. So that's what I did. They had an episode or an issue every year, and it was the Compute Magazine, how to code all these games. Greatest magazine ever for a 10-year-old kid that does not have an Atari, let me tell you. So let's get started. So I created this ultimate vibe coding survival guide, right? And in here on the first slide, by the way, I created this with AI, right, inside of Notebook LM. So if you haven't tried it, fantastic. I gave it some ideas, some concepts, and it helped me, right? So let's get started here. So basically, we want to get to here. We want the island paradise of vibe coding, right? The vibe coding is the easiest part of this, right? It's the aspect of it, like the GitHub repositories, understanding check-in and checkouts, the snapshots on the backend databases. That's the dirty work that we all really need to know and what we do in case of a failure, right? The vibe coding right now is easy. That's the easiest aspect of all this. So we want this island paradise over here. We don't want Mount No version control where it's a volcano, right? And this guy's in a hammock saying, I should have used GitHub and snapshots. Their database is a spreadsheet, right? They don't understand tenancy. They're running a SaaS environment, and so it's just everything's on fire. It's horrible, right? So let's get started by checking this out. Okay. And this is a great title right here. It's all fun and games until you lose data. And let me tell you, in my 30 years, my worst days were data losses, right? Those were horrible because you don't anticipate it, right? It just can happen at any time. You're constantly getting attacked, right? I think at one point we were looking at CrowdStrike. It was telling us we were being attacked over 30,000 times in like an 8-hour shift where CrowdStrike was just defending us. So imagine all it takes is one person getting through that. And now all of a sudden you're going back to snapshots. You're going back to, your version control, whatever you got, at the time. So, okay. So here we got the vibe coding dream, right? It's simple. This is where everybody thinks we are, right? And then we got reality, right? Data loss, security breaches, broken builds, right? Or worse yet, we push something to production and it wasn't production ready. So we got to go back, check out our version control and go back, right? Down here, I put, if it works on my machine, that's not a strategy, right? Anything can work on your machine, right? This is where you got to crank up the emulators and say, okay, I want you to try, a Pixel 9, right? Now I'm going to try iOS on iPhone 16. I'm going to try Chrome. I'm going to try Safari. And then you've got to create like your requirements of, what it can work on. So here we go. We got our phase one. And this is if you're starting a business from scratch, and let's say you want to start this vibe coding AI business. I put this in here because I think it's important. I see so many business owners nowadays with an at gmail.com email address. And not that I use Gmail, but I have a domain name, Jez Digital, right? So it's very simple. You go buy a $20 domain name per year at, GoDaddy or whoever you want, right? It doesn't matter. And then all you do is you go buy the $17 package at, Google for Google Workspace, and you create a professional looking email address like stan@jezdigital.com. It all starts here with your domain. And there's other reasons for that too. Just the trustworthiness. Everybody's going to trust someone who has a Stan at Jez Digital, right? There's also things out there where if you get your business verified and things like that, they want to see a real domain name. So this it also enables, by the way, like authentication and things like that, right? So do yourself a favor, go get a real professional looking domain name and an identity. Okay. All right. Call this phase two, the time machine. This is the start of where we talk about GitHub. All right. They call it the infinite undo button. GitHub, this is an important concept that I read time after time after time on these Facebook groups and everything else where people are like, I lost my production data, right? And it's like, well, you shouldn't have because you should have used GitHub. GitHub is nothing more than a nice organized file system out in the cloud. It's great. They do a wonderful job. You can set things to private, you can set things to public. A lot of times, university professors, people that are doing open source projects, they want to set it to public. I set my stuff to private. I don't need people digging through my stuff. I don't want them to accidentally find something, some sort of key that they shouldn't see, even though, we check for that all the time. But what GitHub is it's a way to do version control so that you and your team work together on your vibe code, right? And so I also heard this thing lately called like vibe teams, right? Where it's like a whole group of people vibe coding together. But to do a vibe team, you're gonna have to understand GitHub, right? So what that'll enable you to do is you're gonna check your code out, right? So let's say we're at version 1, you just wrote it, right? And now you've got some changes. You've ran it through the test, you've ran it into production, you got it at version 1. Now you're ready to go make changes. So you check your code out, right? And now you make your changes and you check it in. That's version 2, right? And so on and so forth. Now, let's say you're all the way up to, let's say, version 9, and you've got a bad bug that no one caught. It's horrible, right? And not only did they not catch it in version 9, they didn't catch it in version 8, right? So you're going to end up going back to version 7. So that's part of the nice aspect of GitHub, right? It's not only can you go back one, right, where you're just doing basically and essentially a backup and restore, right? And you can go back too. And this is just for your code. This is not for the data. So let's not get that confused. The data is in the future. We're going to talk about that. That's snapshots, backups, restores. That's the actual data. This is your code. So this is your vibe code changes. And this enables an entry level vibe coder to compete, with, I'm not going to say senior level coder, right? But an entry level coder, right? Maybe that would, but now I think you could have senior level vibe coders that can compete with, at least mid level, if not senior level. I mean, especially if the senior level programmer is not vibe coding, right? I would take a senior level vibe coder over a senior level developer, right? So I think it's very important that we realize that the days that how we used to code, those days are gone. They're gone forever. Vibe coding's here to stay, right? And so we get into a topic here called SOPs, and this is an important topic. I threw this in on purpose. SOPs stand for standard operating procedures. Two aspects of vibe coding that I don't think are spoke enough about besides GitHub and snapshots are SOPs, which is standard operating procedures. So it's one thing if I know my policy on how to use GitHub. It's a whole nother thing if my team doesn't know the policy. So you create SOPs, standard operating procedures, and you say, this is what we do. We check the code out and we check the code in. That's a new version, right? So everybody's on the same page. It's just work instructions. But nowadays, SOPs are so much better because you can tie them into AI. So in the old days, on an SOP, you could just go what's called vertical, right? Up and down, right? Now you got vertical and horizontal. An instance that I wrote about before was I have an SOP for my camera gear, how I shoot these videos, how I shoot a YouTube videos, right? I use Riverside FM, all my settings, right? So this is pretty cool. It's interactive. You throw your PDF out there, which is an SOP, right? And then they banter with it back and forth, and they can ask questions about, oh, Stan uses a Sony A7 IV camera, right? He uses Riverside FM, right? His audio settings, after he uses enhanced audio, he sets that at 80%. He sets his volume at 50, right? I use a Shure mic. And then you go, tell me more about the Sony camera, the A7 IV. And now you've gone from a horizontal up and down to what Stan's settings are. And now you're going to a horizontal search. It goes out and it's like, oh, Best Buy has that on sale for $2,000, right? Or here's what people are saying about the new Sony A7 V. Maybe you'd find that interesting, right? So this is where SOPs have completely changed. You know, it's completely different than when we originally did SOPs. So, back to the GitHub version control. So version control, once again, to recap, it's nothing more than a really fancy like directory that you check in and out your code, right? And you get different versions. So it's backing up, restoring your code. Also, GitHub integrates with all these softwares, right? So it's like when you're working in like a Claude code or you're working on the back end, we're going to talk about Google Firebase in a little bit. You can integrate with the GitHub. It's called a repository. You're integrating with the GitHub repositories, right? So I think that covers everything on GitHub. Let's get to this. Phase 3. This is what everybody knows. This is actually, if you've watched my videos, this is like everybody's doing this, right? Not everybody's talking about the backups, the bad stuff, right? This is pretty straightforward and easy, right? I've shot tons of video on this. You know, and all this is, it's like we start by usually talking to Google Gemini. Actually, this morning for shooting this video, I talked to it and we came up with this video, right? This idea, the survival guide. And that was from Gemini, right? I didn't think to write a survival guide for vibe coding. And I kind of told it my concept. I was like, you know, not enough people are talking about version control. How do I make that fun, right? Because it's not that fun of a topic, right? Backups and restores. Ooh, it's not that fun to talk about backups and restores, right? So Gemini is like the brain. It starts out prompting everything. And then the Google Stitch, I can't say enough good stuff. I've been doing a lot of videos lately on the Google Stitch. That's your UI. You used to have to pay for Figma. Now you got Google Stitch for free. So I don't know if it's going to stay for free, right? But for now, it's free. Now, I'm assuming that's within, by the way, this is all within the $17 package of Google Workspace. So your phase 2.5, I would say, is go out there, get yourself a $17 license of, Google Workspace, right? Because it comes with Gemini in it. It's fabulous. It's got some Firebase on the back end. And we're going to talk about that in a little bit, right? And then the next thing is the actual vibe coder. So this is my go-to right now, Claude Opus 4.6. This thing is amazing, right? Not only is he doing agentic coding, but he's like doing self-debugging logic, right? I told him the other day, I was like, you're wrong. It came back and it knew that I did the emulator wrong, right? So this thing, I don't know how it saw it, right? But it was like, no, you're running it wrong in the emulator, right? And he was right, right? But Claude Opus is amazing. It's next level, right? If you can't afford the Claude Opus, Google with that $17 package, you also get the anti-gravity, which is a nice IDE. It's not quite where the Claude Opus is, but it's coming along nicely. You also get AI Studio within that workspace, right? And so that's another one. And inside that Google Workspace, they also have let's see, it's Google Workflows, right? So for some automations, and there's just a lot of free AI tools within that. And of course, you get what I wrote these basically slides with, which was Notebook LM, right? And this is the easy part. I think we all like to do this stuff. This is easy, right? So now, once you got your code written, on to phase 4. This is what I call the vault, right? It's the backend architecture. So with the backend, you kind of have to know what you're going to develop in before you write the vibe code. So this kind of goes hand in hand with phase 3. I just put it in this order just to simplify things. For what I use is called Firebase by Google, right? It's a BaaS, which stands for Backend as a Service. You have software as a service, which is like Salesforce, but this is actually where you utilize their hardware in the Google Cloud. And it's really nice for me because everything's built in. It's got what they call the bouncer, right? Which is authentication, right? You can go in the authentication. You're like, let somebody who has a Google account or a Microsoft account, Facebook account, let them log into my system, right? And you have what they call the warehouse, which is cloud storage for assets like your PDF and or your videos or your pictures. And then you get to decide which kind of database do you want, right? Do you want a NoSQL database, which is kind of the default for that? Or do you want to utilize Data Connect and go back to Postgres, which is in the Google Cloud, but it has this nice interface right within Firebase, right? And by the way, over here you have traditional. You've got people that still use spreadsheets for production data, right? And as you can see here, it didn't fare well on the volcano, right? The nice thing about this, the backend stack that we're using here, you can use snapshots, right? So you got your automation of your backups, makes restores. Nobody wants to restore data, but can you imagine trying to restore a spreadsheet? That's not going to bode well for you. So here's just a key insight that I wanted to drop down here. Think about this. Your professional code, no matter how good your code is, it's only as good as its data integrity. So your code, you can write the most beautiful code, but if you don't set the back end up right, your code's going to be worthless at the end, right? So I talked earlier about multi-tenancy, and what multi-tenancy is companies like Salesforce, SaaS companies, they create tenant architecture. So if you've got data out there on Salesforce, you don't want your competitors to accidentally see your data, and you don't want to see other people's data, right? So what they do is they set up basically org IDs or tenant IDs, and you've got lock boxes over here, right? Tenant A, tenant B, tenant C, right? And all they're doing is keeping your data separate. So they're still storing it on the same massive database, right? To keep costs down, because they're not getting everybody their own server, right? But what they're doing is they're separating the data by tenants, okay? So that's very important. If you're going to try to build your own SaaS, you've got to understand what multi-tenancy is. So it's very important for you to research that and understand it before you try writing your own custom CRM that you're going to sell to the world and you didn't build it for tenancy. Because at the beginning, it's fairly easy to tell AI, I'm building this for tenancy, right? If you're building a SaaS, you might as well throw multi-tenancy. If you're building anything that you may sell in the future, set up multi-tenancy. So I wanted to teach you guys something also. A lot of people don't understand what this is, the ERD. What an ERD stands for is Entity Relationship Diagram. I did these 30 years ago at Purdue. I was taught how to do these. And still to this day, I still do them. They're incredible. They're very, very simple. You just have to understand them. This will help you set up your database structure. And it's very important to understand if you're going to vibe code something, you better understand the database structure, or you're going to be in a world of hurt in about a year, probably shorter than that when you build it wrong. So this is in response to talking about a relational database like Postgres. This is not regarding NoSQL. We'll get to that in a second. So here's an example that I did, right? You've got a college student here. He's in a class that's called a student class, right? And up here is the class description. And then you got the professor here that teaches the class, right? Now, the first thing you'll notice if this is a SaaS model of all the different college universities, they have tenant IDs. So Purdue University is going to have a different tenant ID, right, than IU University. So, we don't want to mingle IU students with Purdue students. We want to keep them separate. So that's where your tenant ID comes in, right? Now, let me explain this. And how this works is when you originally build this out, you're like a student takes a class and the class has many students, right? You can have a student can take many classes. That's called a one to or a many, right? A class can have many students. So that creates what's called a many to many relationship. Let me say that again. A student can take many classes. A class can contain many students. Many to many. Anytime you can say that, you have to break that out into its own table called student class, right? Could have called it class student, whatever you wanted, right? And those, all they do is create a unique table that sits between these two that has foreign keys. You got a primary key, which is the identification, right? And then you got foreign keys, just a foreign key, which is going to class, and a foreign key over here to student. This is where you'd put your grade. You couldn't put a grade in the student table. You couldn't put a grade in the class, right? This is just identifying professor, course name, schedule, Tuesdays, Wednesdays, Thursdays, 10 a.m., all that stuff, right? And down here, the student, you couldn't put every grade in that. That's where you create this, right? So this would say my identifier, right, for Stan Jasanowski, Bio 101. And, I bet I didn't get an A in that. Probably like a C. I was not a science person. Any AI classes, I would ace. I actually took AI 28 years ago, I think at Purdue, was my first AI class. And it was nothing more than if-then statements, right? And it, probably most likely, it's still just a bunch of if-then statements. It's just running a lot better computer, right? So over here, you got professor. You get a professor who teaches the class, right? And so that just is a foreign key right there. It says F key, FK, right, for foreign key. And it gives the professor's information right there. So I wanted to talk about this because this is really important to understand. I hope some of you go back and watch this again, because when you're building databases, you can go tell it, hey, help me build this database. But if you don't understand this, you aren't going to understand how it's writing the tables. The other thing too, a lot of times what we called bottom-up approach. What a bottom-up approach is, you kind of look at the screen or the reports that you're using, right? And if nowhere in the system they track student's middle name, well, why have it in the database, right? You'll see I have first name, last name here. I don't have student's middle name. If I've never had it on a form or I've never had it on a report, why would you track it? But what you do is you go through, you build your report, you build your forms, and you go back and you build the databases based off of those forms or those reports. So, and then you've got, before we get into this, we're going to talk about NoSQL real quick. So NoSQL, you have a relational database or a NoSQL database. A NoSQL database is more of a flat databases. Those are really prevalent in the early 2000s with a program called Lotus Notes. And those are different. They can't query the same, right? In those, the queries are like collections, right? Where you wouldn't want to do a university database on a NoSQL database because NoSQLs are made to be really fast, right? And really responsive, right? Relational databases are meant to keep tons of data. NoSQL can still keep a ton of data, but it's really flat and boring, right? It might be like how Stan did on a game, right? Keeping just high score, right? Just something real basic. It's Stan, his nickname is Jez, his high score in Retro Bowl is 17-0, right? His best season. I love the game Retro Bowl, by the way, if anybody out there has tried it. Fabulous. Reminds me of my childhood playing old Tecmo Bowl. But that's kind of what NoSQL is, right? And on Firebase, they've got the default database is like a I think it's called Firestore, actually, and that is their NoSQL database. So that's the differences in databases. Also very important to know. But here you go with another SOP, which is, remember, standard operating procedure, right? This one talks about, it's super important, right? To make sure tenant ID is critical, right? And we talk about the risk of, messing around with the tenant ID and not doing a tenant ID correctly, right? With this, you're going to have your data show up in other people's databases or vice versa. We don't want that. We can't have a SaaS application like that. So the SOPs on that are also critical, right? And now phase 5, what I call the emergency hatch, snapshots, right? Backups, restores, you know, your server is only as good as its backups. And, so many people don't test backups. So I used to work in private equity. We would buy companies and I would go into these companies. Every company we buy, I'd go to test their first thing I do is want to test restores or backups. Nobody knew. There was no SOP, right? They were all terrible. So what I finally would do is there was there was actually a device that you would bring in and you'd hook it up to the server and it would just automatically back everything up. Just make a copy of that entire thing. And every place that we bought, the first thing I would do is go get one of those devices and put it right next to the server and plug it in and back up the entire server, because I knew no one ever tested those backups, right? No one tested restores. No one. They were terrible. So it's scary how many businesses have bad backups. So here we got a picture of the server on fire. It looks like a nice server rack, but they didn't invest in snapshots, backups, recoveries, offsite backups, anything. They invested nothing. They did some nice vibe coding. They threw it on the back end and they never tested it once, right? So here you go, locked down here, database snapshots. All this is doing is saying, hey, I want 1 time a day to back up my database as a snapshot, 2 times a day, 3 times a day. I'm sure there's databases that are like every minute, right? They're that important. So when I was working in manufacturing, we'd usually do it about 3 times a day. Okay. So this is a point in time restore. So it's very important to have an SOP on this. And it's also important to have like an SLA, which is like a service level agreement, right? Where you're talking about, okay, we're going to have 99.9% uptime, right? And what happens if you have downtime, right? Does a customer get a monthly refund? I don't know. It's up to your SLA, service level agreement. Very important. Okay, phase 5, backup strategy. This is super important, right? This is the life raft, right? 3, 2, 1, right? That 3 stands for 3 copies of the data, right? 2 different media types, and one of them has to be stored off-site. You don't want everything in the building, right? If you have a tornado or a fire or whatever, you lose all your data. What's going to happen? Your company's going to shut down. You're just going to close the doors. So this is called the 3, 2, 1 backup strategy, right? I had some databases that were so important that I would do backup one day from a system in Cleveland, and I'd run a different database the next day in Indiana, right? And I actually had 2 different people set them up, and they would audit each other's work, right? Because the biggest problem with backups and restores is human error, right? So the way that you get around that is to have somebody else audit the work. So, and I can't say enough about audits. So on your backups, so audit your data, right? Your restore's only as good as the audited, right? I had a friend who went to restore a server, and he was a consultant, and he goes in there, and whoever had set it up didn't set it up right. They were backing up nothing, right? They were basically selected like no directories. So it showed that it was successful, right? But they didn't select any directories to back up. So it just told them every night, hey, and because the guy was like, oh, my backup said they were successful. And he goes and looks at him. He's like, well, you didn't select any folders, right? So that's why testing is important. So, all right. And then you need an SOP for the restoration runbook, right? This is where, okay, we got to now restore it, right? What are the steps to restore, right? This is step 1, step 2, step 3, right? Simple as that. It's just a nice PDF. There you go. And here's your bulletproof checklist. This is what I want to be, just on a beach, drinking a boat drink. Life is good. I don't have a Gmail account. I'm using GitHub. I'm using multi-tenancy over here. I'm happy as a lark, right? So basically the checklist is, hey, domain, right? Check. We don't want a Gmail account. GitHub, check. AI stack, check. what we're doing, that's the easy one. Everybody's good at this, right? The blueprint, check. Multi-tenancy, data silos, survival, the 3-2-1 method, right? That's all we got to do. So basically, I want to wrap this up with talking about, you're only as good as your backups. I can't reiterate that enough. And I honestly think everybody who enjoyed this video, the first thing I would do if I was you, I would go watch another video on GitHub, right? And really understand GitHub, because it, to me, is the most important. And well, it's really tied with snapshots and backups, right? Those two are more important than your vibe code, right? To understand, those two are more important even than multi-tenancy, because there may be a lot of times you don't even need multi-tenancy, right? You're just writing something for yourself. If you're writing something for yourself, you don't need multi-tenancy. But the GitHub aspect of it is super, super important. I can't say enough. So, but anyhow, I appreciate everybody watching tonight. If you've got any questions, please put them in the comments down below. Like and subscribe, and we will see you tomorrow. Bye-bye.